Yeah, hi there. In this tutorial, we are going to cover how to engineer a date column which we receive in a data set. So, date columns are special columns in a way that any date component contains a number of other components. So, in a way, date variables can be used to enrich our data set. So, and from a given date column, we can extract the different components of the dates like month, quarter, day. We can even time component also, and then we can use if you want we can use these different components and in our machine learning model. So it's important to understand that when we get the date variables, we should not treat it as a categorical variable, because by default usually when you read a data from a file, it will be treated as object if it contains a date timestamp, unless you specify the data type at the time of reading. So we need to convert it into date time so that it is treated as a date time variable, not as an object or a categorical variable. So most of the common attributes that we get in our data analysis are like, which are related to dates, are like invoice date, payment date, due date, birth date, joining date. So all these date type of variables we should be careful about while dealing with, so that they are not treated as categorical, they should be converted into date time. Okay, so how can we now since these contain date time data, and while passing any data to machine learning, we need to ensure that it is in the form of a numeric data so that it can handle it properly. So we need some way to transform these date values into some sort of numbers. So one common way is to, let's say, we can extract the different components of a date. So for a given date, we can extract from it month, year, day of the week, and in this way we can use those and put it in a separate columns like uh, pay, payment. For example, let's say there's a column called as due date, then we can say due month or due day or due year, in that way. So that is one approach in which we can extract different components of a given date column and we can use it. So that's the one approach. Now another approach is we don't extract different components of a date column. What we do is let's say if we have two columns, like there is a due date and there is another date, the actual payment date, the date when the actual payment was made. So instead of extracting different components from these two dates and giving it into a machine learning model, uh, the another approach says that let's use these two date columns and uh, find out some sort of a relationship between them and extract that relationship. Let's say we have a due date and then another column is a payment date. So then I want to compare whether the payment was done before the due date or after the due date. Okay, and then we can get a number. So using this number, we can pass it as an input to the machine learning model. So the advantage with the second approach is that we will not have that many huge number of columns by extracting different components of the dates, and with just one or two column we can get the required number, which is in a way representative of two date columns, and that can be used in building a machine learning model. So let's take an example. So I'm just first loading the libraries NumPy and Pandas, and I'm manually creating a data frame. This data frame contains customer ID and due date and the payment date. So it looks like this. Yeah, it looks like this. Is a customer ID. There are five customers, and let's say they have a certain amount to be paid, maybe credit card payment, you can say. This is their due date, and this is the date when they actually made the payment. So some customers made payment before the due date, some customers made payment after the due date, and some made on the due date exactly. So now Now, before we go further, let's see what is the data type of the data frame. So data type says that customer ID is integer, that is okay. But these two columns, which are date columns, due date and payment date, these are not, these are coming as object. So as the first thing, what we have to do, we have to convert it into their appropriate date time column so that we can then perform date time operations on these columns. So what I'm doing is I'm just converting it into date time, pd dot to underscore date time, and name of the column I'm passing it, and assigning the result back to the same column. So similarly for the due date and payment date. So now if we check the data types, both these columns are coming as date time columns. So this is what they are looking now. Now they are ready to be treated as date time columns, and let's say following the first approach, if we are extracting let's say two components from each of these columns, which is month and the day. So we have due month and due day, and similarly payment month and payment day. So this is what, so, and we are extracting using data frame dot column name dot dt, which represents date, and then the date component, which it could be month or day. So I'm extracting two components only, month and day, both for due date as well as for the payment date. So this is what we have now. So these were the three initial columns that we had. Now these four columns we got additionally created. Due month, so this is due month is 8, due month is 9, and so on. Similarly due day is 2 30 25, 2 30 25. Similarly payment month and the payment day. So that was the approach number one, where we remove these date columns and create the we create the new columns based on the components that we extract from the respective columns. Now, following the approach two, which said that using two date columns, find a relationship between them and try to extract uh, some value by comparing those two date columns. So what I'm doing is I'm just subtracting the due date, payment date from the due date. So basically, my expectation is, the general expectation is that the payment would be done within the due date. So payment date, I mean, in order for any customer to avoid any finance charges or to avoid any fine, they should be making payment before the due date, or at at max on the due date. If they are paying after that, then they have to pay some finance charges. Yeah. So usually we expect that I mean, for a good customer, he would be making payment within the due date, so the payment date would be less than the due date. That is why I'm subtracting the payment date from the due date, and whatever the difference is coming, I'm just simply converting it into days. So now we get like this. These are the four columns which were coming initial, like in the previous step. Now we don't need it because we are more interested in this column, overdue underscore days. So whatever the result was coming, I stored it in overdue underscore days. Now this is what we have. So from this column, we get some sort of relationship between due date and the payment date. So it means this customer with customer ID 1 paid 10 days after his or her due dates, and the second customer paid uh, 20 days before the due date. This customer paid exactly on the due date. So in this way now, instead of using all these four columns, 4 plus 2 6 columns, we can use only one column, which is overdue days, and use that column as the input column for our machine learning model, and uh, that will help us by having the lesser number of columns. And again, once we have this column, we can create one more feature column. Let's say now we have this overdue. We know any customer who overdues should pay the fine, right? So let's create another column which is fine, uh, fine charges, some finance charges. So what I'm doing, I'm just simply applying a lambda function on it. So wherever it is greater than 0, so I'm saying the finance charges should be 1, indicating that the finance charges should be applied on that, otherwise no. Oh, just a small correction in the logic. So wherever the value is less than 0, that is there is a negative value, it means the customer overdue. There the finance charges should be applied and not otherwise. So and I'm up, just applying this using dot apply. I'm applying this function on this overdue underscore days, and wherever the value of individual value is less than zero, set it as one, zero otherwise, and store in the new column which is finance charges. So if you see for this customer, the due date was 2nd of August, the payment was made on 12th of August, so it means there was a delay of 10 days. So if you see this overdue days is 10 days, which is negative, indicating minus 10 days, indicating that he went beyond the limit, that is beyond the due date. He exceeded by 10 days, and definitely now he has to pay the finance charges. So that is why we see finance underscore charges as one. Whereas whereas the other this customer, the due date was 30th September, the payment was made on 10th of September itself. So the payment was made 20 days earlier, and so obviously no finance charges. So in this way, using the uh, date column, we can extract the different components, and that we can use as for machine learning building. Otherwise, what we can do, if we have two columns or more columns, in such a way that we can uh, extract some value based on some relationship between the columns, then let's use that value as an input to the machine learning model, instead of extracting the different components like we did in this case, overdue days. And it can also help in building some additional feature columns, like in this case finance charges was set as 1 or 0. So yeah, the key point to notice, make sure that the date column is actually the date, it should be casted to the date time. It should not be treated as a categorical column. So whenever you read the data, make sure it is not in the object data type. It should be converted into data time, and then you can use that particular column for your analysis by extracting the different features from it. So that's it in this tutorial. Thank you.